Okay, so let me read the question out. An investment analyst claims that the average annual return on services in the tourism industry is 12%. You want to test whether this claim is true. You collect a random sample of 36 services in the tourism industry and find that the average annual return is 10%. With a standard deviation of 3%, use a 5% level of significance to test the analyst's claim. So, colleagues, this topic is on hypothesis testing, all right? You just want to test a claim, basically. That's what's happening here. You want to see if a claim holds true. Okay, so here the claim that is there is that when you invest in the tourism sector, your return is supposed to be 12%. Okay, that's the claim that is there. Okay, so what has happened is we've taken a random sample of 36 businesses in the tourism sector and we found the annual return is 10%. Okay, so we want to see if this claim that if you invest in the tourism sector, your return is 12%. Want to see if this claim holds true. Okay. Because right now we've just got a sample. This 12% is for the population. This 10% is for the sample. Colleagues, do we remember what a population and a sample are? Before I go further. What is a population and what is a sample? Hello? What is the difference between a population and a sample? Madam Sylvia? Mm-hmm. Yes, yes, that's correct. A population is the whole group. A sample is a subset of the group. Colleagues, are we all okay with that definition? Are we all okay with that definition? Because there are more statistics questions coming, so you have to you have to understand these terms. So here, as I said, we want to test the claim, okay? That if you invest in the tourism sector, your return is 10%. We want to see, does this claim hold true? Okay. So as I said, this is hypothesis testing. So this is how we answer it. I'll put it in a step-by-step process. Okay. Step one, state the now and alternative hypothesis. Okay. The now hypothesis, which is written as HO, is basically what is believed. Okay, it's the norm, what everyone generally accepts. Okay. Then the alternative hypothesis is challenging the now hypothesis. Say that no, I think the now hypothesis can be false. Okay, so the null hypothesis, what is generally believed, what is generally accepted. And in this case, the general acceptance is that if you invest in the tourism sector, your average return is 12%. Okay, so here this is the null hypothesis. Okay, mu, this letter mu represents the average. Okay, we're talking about the average return. So we're saying that the average return in the tourism sector is 12%. That is the null hypothesis. Then the alternative hypothesis, as I said, it challenges the null hypothesis. So the alternative one is the average return in the tourism sector is not 12%. Okay. It can be greater than 12%. It can be lower than 12%. Okay. So any questions before I move further? All right. So after you've stated the now and the alternative hypothesis, step two, calculate your test statistic. Okay. With these hypothesis tests, okay, the test statistic which were calculated. Colleagues, are you getting me? You can't get me. Hmm, what's happening now first here? Just hold on. Hello? Can you get me now? Okay, can you see my screen now? Okay, so yes, I was saying step two, we need to calculate our test statistic. Okay, with these hypothesis tests, your test statistic is tested against a critical value. That's what helps you make your decisions. Okay, so step two, we need to get our test statistic. Okay, so before you get your test statistic, okay, find out the sample size. Okay, if it's greater than 30, this is the formula you use here. Okay, if your sample size is greater than 30, this is the formula you use, and it will be a Z test. If your sample size is less than 30, then it becomes a T test. Okay, so you'll be using T tables and the likes there. Okay. So here, since our sample size is greater than 30, so we'll use this formula. Okay. X, all right, represents the mean from the sample. U represents the mean from the population. Okay. Sample mean minus population mean divided by S. Maybe let me write it in like this so that sample mean X minus population mean so sample mean minus population mean divided by the standard deviation divided by the square root of the sample size. Square root sample size. Colleagues, is this okay? This is the formula for getting out your test statistic. Is that okay? Since it's now written in plain English, not in symbols. Okay, so our sample mean is 10%. So it's a 10 minus population mean 12%, 10 minus 12. The formula. Yes. This one is given. Okay. I will show you where you find it in the exam. Standard deviation. Yes. So you're going to say 10 minus 12, that is negative 2. Square sample size, remember, is 36. Square root of 36, that is 6. Okay, here remember order of operations. Okay, we work on these brackets here and also these ones here. Okay, so 3 divided by 6, that is, we can still leave it as a fraction. Okay, 3 divided by 3, 1. 3 divided by 6, so you have a 1 over 2. Or maybe let me use the board so that it's people are, should follow along. So we have a negative 2 here over 1 over 2. All right. So you just multiply this 2 at the bottom with this one 2 times negative 2, you get negative 4 over 1. Negative 4 divided by 1, that is negative 4. Excuse me. Let me go back to the previous page here. Okay. Negative 2 divided by half. So remember with fractions, when you dividing, you change the sign. Yes. So these are shortcuts. These are shortcuts that I want you to know. Okay. Anytime you see a fraction at the denominator, just take the denominator and multiply it by the numerator, like how I did here. So that we envision what is happening here. Okay, so here this middle point represents the fail to reject null hypothesis region. Okay, this region in the middle. Okay, then these ones in green, they represent the region to reject null hypothesis. So what is going to happen here? Okay, we need to first get our critical values, and then we see where our test statistic falls in this. Think of this as a number line. Okay, the test statistic is going to fall within this number line. Okay, we need just to first know our critical values. Okay, so we've got our test statistic, it's negative 4. The next thing that we need to do is we need to have our critical values. Okay, so when you have a significance level of 5%, the significance level, what it represents is uncertainty. Okay. Remember, whenever you are conducting a test, you can never be 100% sure. Okay. So you always leave room for error. So think of the significance level as the room for error. Okay. Then your confidence level, as it says, confidence level, how sure you are in taking a test. Right? So whenever you're doing this type of test, it's you to choose your confidence level. And once you know your confidence level, you have your significance level, because both of them have to add up to 100%. Okay, so significance level, your uncertainty. The confidence level, how sure you are. Okay. So with a confidence level of 95%, okay, your critical values are negative 1.6 and 1.96. Okay. And your confidence level is 95%. I'll show you how we got these 1.6s. Okay, colleagues? I'll show you how we derived these 1.6s. Okay. When your confidence level is 95%, your critical value is negative 1.6. Okay, so you have two negative 1.6s. The reason why we have these two critical values is because of this in the alternative hypothesis. Okay, in our alternative hypothesis, we said that our average return is not 12%. So it can be higher or it can be lower. Okay, so basically we have a two-tailed test. Okay, a two-tailed test just means you've got two rejection regions. Okay, so because of this not equal sign here, that's why we have two critical values here. Okay, because of that alternative hypothesis. That's why we have two critical values. If the alternative hypothesis had a less than sign or a greater than sign, then you just have one critical value. But if it has this sign, two critical values. So as I said, the Z statistic that you calculate, you're going to put it on this number line. Okay. And you see where it falls. So we can see that negative 4 is less than negative 1.96. Negative 4 can fall somewhere here. Okay, negative 4 can fall. It falls in this rejection region. Okay, so since it falls in the rejection region, okay, we have enough evidence to say that the null hypothesis is not true. Okay, we have enough evidence to reject the null hypothesis. Okay, so you're going to say since the test statistic, this negative 4, is less than the critical value, since your test statistic, negative 4, is less than the critical value, which is negative 1.96. We have enough evidence to reject the null hypothesis. So we're basically saying the average return is not 12%. Any questions? Yeah. Okay, okay, let's backtrack. Let's backtrack. Okay, let me backtrack. Uh, uh, yes, madam, after. Okay, here. Okay, when we're solving for z, 10 minus 12, negative 2. Here at the bottom, square root of 36, that is 6. So you have negative 2 divided by 3 over 6. Okay. Then we simplified this 3 over 6 of, so it becomes half. Then we multiplied this 2 at the bottom here with this 2 at the top. Okay, madam? That's how we ended up with negative 4. So once that was our test statistic, okay? Once you've That's the test statistic that we've calculated. Okay. Now, once you've got your test statistic, okay, just remember this because there are many hypothesis tests. So just remember this. Whatever hypothesis test that you are doing, okay, it's either you're going to compare a test statistic and a critical value, or you're going to use the p-value rule, where you see if the p-value is less than 0.05. Okay. So here, that test statistic, that negative 4, we wanted to compare it with the critical value. Okay. We want to compare it with the critical value. So as I said, when your confidence level is 95%, your critical value is negative 1.96 and positive 1.96. Are we okay with that, colleagues? When the critical value is 90, yes, 95%. Okay? When your confidence level is 95%, then your critical value is 1.96, positive and negative. Okay. Any questions on that, Faith, before we go, Faith? Do we remember why we have two critical values here? It's because of the alternative hypothesis here. We've said the average return is not 12%, which means it can be less than or it can be greater than 12%. Okay. That's why we've got two critical values. All right. Because our alternative hypothesis has said the return is not 12%, but it doesn't specify whether it's greater than or it's less than. Okay. Even this hypothesis test hasn't answered, okay, what percentage is it if it's not 12%? It's just destroyed that claim, but it hasn't given a new percentage. Okay, colleagues? So, due to that alternative hypothesis, that's why we have got two critical values. Is that okay, Mr. Foster, Madam Helen, Mr. Kasono? But why we need two critical values? Ask your questions. Ask your questions. I actually thought this one would take just 5 minutes, but ish, it seems we might spend some time. But ask your question. Okay. Let me even get the Z table so that we see where this 1.96 is coming from. Because I think people, that's the next question on their minds. So where is that 1.96 coming from? Okay, let me show you. Let me just get the Z tables. So for more context, as I explain where it's coming from. So this white region, this represents the confidence, the confidence level. So it's 95% here. Remember, the significance level is 5%, so you split here, 2.5% here, 2.5% here. So we can look at this in two ways here. If we look at this table for the area to the left, this negative z-score table here, okay, this probability is representing 2.5% here. So you can here amongst these numbers here, okay, these are the percentages now in decimal form. Okay, so 2.5% is 0.025. Okay, here 0.025 here. And remember how we read these tables? Here we've got a negative 1.9 here. And we've got a 0.6 here. So 1.9 plus 0.6, that's how you get the 1.96. So that's where that negative 1.96 is coming from, negative and positive. Okay. That 2.5, this area here, this green region, this 2.5%, all right, is represented here as this 0.250 here. So when you correspond this 0.25 here, that's how we're getting 1.9 here and a 0.6, which gives us 1.96. That's one way of looking at it. Okay. Can I go to the second way of looking at it? Or are we satisfied with this one? Okay, the second way of looking at it. If you look at it from this angle, this is 2.5%. 100 minus 2.5, that is 97.5%. Okay, so this area in blue is 97.5%. So you look for 97.5%. In decimal form, it's 0.975. So you look where is 0.975 here. Okay, 0.975, and when you correspond it, it's 1.96 here. Here it is 0.06. So when you add the two, 1.9 plus 0.06, that's how you get 1.96. Okay, colleagues, that's how that magical 1.96 is appearing. I hope I haven't confused you more, but that's where the 1.96 is coming from, those tables. Okay, colleagues? In the exam, you don't have to show where it comes from. Okay? You just calculate the test statistic, Then knowing that, okay, confidence level is 95%, so my critical values are 1.96. But in case you forget that, maybe you can use that technique I've showed you. Divide the table into percentages, look for the area. Once you find the area, you find the corresponding values. Is that better, Madam Sylvia? Mr. Casono, is that better? Mr. Emmanuel? Yes, so that's where they are coming from. Yes. No, no, they'll just give you the significance level. They just use using a significance. So here they told us significance level is 5%. Use a 5% significance level. So as I said, think of the significance level as your level of uncertainty. So 5% uncertain, then 95% certain or confident. Okay. So your significance level will tell you. Okay. But in real life, and when you're doing your researches, it's you to choose for yourself. Okay, I'll use this confidence level, and this will be my significance level. It's for you to choose. Okay, so colleagues, it's just a simple step process. Step one, you just make the now and alternative hypothesis. The now hypothesis is what is believed or what the claim is basically. Because in the question, there's going to be a claim. So you have to identify that claim. And that claim will be your now hypothesis. Okay. In this case, our claim was when you invest in the tourism sector, your return is supposed to be 12%. Then the alternative hypothesis goes against the now. It's the opposite. Okay. So if the now is saying is, the alternative is going to say is not. If the now says less than, the alternative will say greater than. Okay. Just know that the alternative is the opposite of the now. After you get your now and your alternative hypothesis, step two, you get your test statistic. Okay, using this formula we used here. Okay, you calculate your test statistic. Okay, our test statistic is -4. Once you've got a test statistic, then you know, okay, this is what I'm going to compare against the critical value. Okay, what I'll compare. So in the exam, you just draw a number line like this to make your life easy. Okay, draw a number line. Okay, then your critical values you will state, you will put them. So here, critical value -1.96 and negative and positive 1.96. Then after you've drawn this number line, okay, you can put 0 here in the middle. Then you're going to say, okay, now this test statistic, where is it falling on this number line here? So in our case, it's falling in this reject region to reject the now hypothesis. Okay. So since we've seen it's falling in the reject region, it means our decision for this test is that we are going to reject the now hypothesis. Okay. You just reject the now hypothesis. That's so you do not come up with your own percentage. No. Okay, you just reject. Yes. Any questions, colleagues? Are we going to attempt this question in the exam?